Last time we talked about sources of brain damage, typically from the outside, right? Closed head injuries, infections, heavy metals. Uh, this time we're going to talk about neurological disorders that aren't necessarily caused by outside sources, but that we know a little something about disordered function of the brain. We'll talk about epilepsy, Parkinson's, MS or multiple sclerosis, and Alzheimer's disease. Epilepsy is a disorder in terms of the activity of your brain, right? So we've got coordinated but uncontrollable brain activity as one part of the brain is communicating with another part of the brain through electrical impulses, coordinated, maybe across one hemisphere to the other, for example, but uncontrolled, right? So not directed toward any cognitive task and feeding back on itself oftentimes. You can see evidence of epileptic spikes with EEG helmets that are picking up on electrical signals. You can see spikes of activity. Um, Oftentimes, this crosses hemispheres across the corpus callosum or across the hippocampal connections, hippocampal commissures, but it can be within one hemisphere as well. So you can pick up with an EEG where the activity is going on, see if you might be able to do something about it. These epileptic spikes can lead to spontaneous seizures. So sometimes you can see the spikes and there's no seizure activity, but oftentimes you get seizure activity. And seizures may or may not involve convulsions. So sometimes when we think about epilepsy, we just think of convulsions where somebody is moving uncontrollably, but not all seizures are going to involve convulsions. We'll talk about that on the next slide. Epilepsy or seizure activity more generally is more common in childhood and early brain development rather than in adulthood. And this is likely because the connections between brain centers are still developing as we're forming synapses and dendritic relationships between neurons over long distances. Those connections may be built in a way that doesn't function as well as it could. So as I mentioned, not all seizures involve convulsions or uncontrolled movement. Some of them do, and these are what we would call tonic-clonic seizures that are in the generalized seizure category. So seizures will fall into either a generalized category where you get general effects and general activity of the brain and ultimately psychology, or they can be focal or partial, which means that rather than being general, you have localized effects and localized activity. Generalized seizures can be grand mal or tonic-clonic. This is what we think of when we think of losing consciousness and having muscle convulsions. People might fall to the floor and move uncontrollably, not be aware of where they are. This is a grand mal or tonic-clonic seizure. Absence seizures, sometimes known as petit mal seizures, involve a disruption of consciousness but no convulsions. This is seen sometimes in children. Sometimes it'll look like a child is sleeping with their eyes open as they've lost consciousness, may not have awareness of where they are, but they're not convulsing or moving uncontrollably. Sometimes that might be an absent seizure. Not all the time, but that's what an absent seizure might look like. So these are generalized, right? I lose consciousness generally, and then I either convulse or I don't. Focal or partial seizures can be simple, where you don't lose awareness at all, but you get sensations or convulsions in one part of the body. So maybe my hand tremors or my leg shakes due to brain activity that's localized to a particular part of the body, and instead of generalized, causing general loss of consciousness. Complex partial seizures can lead to impaired awareness. So you're not completely losing consciousness, but you may partially lose conscious awareness. And people having a complex partial seizure can sometimes perform automatisms, where you do long sequences of automated motor behaviors. So you might be playing a video game and experience a complex partial seizure and put down the controller, walk to the refrigerator, and grab some milk to make cereal, and then the seizure might end, and you might not quite be aware of why you're getting the milk. You're doing it kind of automatically. Okay, so you're not completely losing consciousness and control, right? You're still behaving in a way that might appear as though you know what you're doing, but you've impaired awareness of those actions. Parkinson's disease is our next disorder. It involves, um, it's relatively common, about 1% of the population over 55 and increasing with age, Parkinson's disease cases. Primary symptoms of Parkinson's disease are motor related, involving tremor or stiffness, muscle rigidity, slow movement, a mask like face, as you can't control the muscles of your face. Cognitive symptoms come later as it becomes difficult to um, learn new things or to engage in skills and that sort of thing. The causes of Parkinson's disease are degeneration of dopamine neurons, particularly dopamine neurons that begin in the substantia nigra in your midbrain. Those dopamine neurons start in the midbrain and then they go control your motor centers of your cerebral cortex. As those dopamine neurons in the substantia nigra degenerate, it leads to degeneration of your motor centers as well. So you can treat Parkinson's disease with L-DOPA. We've talked about this way back earlier in the semester, which can turn into dopamine. So if my dopamine neurons are degenerating, I can ramp up dopamine activity a little bit to get some symptom relief. Deep brain stimulation also seems to be helpful. So this is dropping electrodes down into the brain where motor neurons are connecting to stimulate those neurons so that you don't get a cascade of damage as much through lack of activity. The next disorder is multiple sclerosis, or MS. MS is caused by damage to myelin sheaths. So our good friends myelin, right, which wrap around the neurons in your peripheral nervous system and your central nervous system, um, and help our neurons to communicate more efficiently and more quickly. In multiple sclerosis, you get damage to myelin sheaths as the myelin hardens and degrades over time. Um, the symptoms of this are the early symptoms are symptoms you might expect from an inefficiently functioning nervous system, right? So ataxia, loss of fine motor coordination, weakness or numbness in the extremities, especially your fingers and your toes, and visual issues, lack of clarity in vision, issues sort of focusing. Now, why would these symptoms arise from degenerative myelin? Well, these are the kinds of things that need fast, efficient neural communication. So to get all the way from my fingers to my brain, or all the way from my brain to my fingers for fine movement, these are the longest neurons that we have in our body, to our fingers and to our toes. So if my neurons are getting less efficient, those are the first neurons that are going to start showing symptoms because it's harder to get the signal that far along down the chain without myelin. Vision is one where the activity needs to be very fast, right? So if I close my eyes and I open my eyes, I need to be able to get the signal as quickly as possible to the back of my brain to start processing because I'm going to start moving my eyes around and my brain needs to keep up. Right? If that signal becomes less efficient, it's going to be harder for me to process the information as well. It's going to be harder for me to see things clearly. What causes multiple sclerosis? Well, we don't 100% know, and we don't have a cure for it right now. But one primary theory is that it's an autoimmune issues are going on, where your immune system is actually attacking the myelin. We do know that multiple sclerosis is not highly heritable, so monozygotic twins only have about a 25% concordance rate. If one twin has MS, the other twin only about 25% of the time will have MS as well. So likely environmental factors being involved in terms of how we interact with the environment over time and how our immune system changes over time. The last disorder we'll talk about is Alzheimer's disease, which you likely know is a disease that affects memory and other cognitive functions. When somebody has Alzheimer's disease, you see a progression of cognitive decline. Now, it's normal for people who are aging to demonstrate memory issues over time, but in Alzheimer's disease, the decline is more extreme than is typical, okay? Ultimately leading to dementia, where you have issues not just with memory, but with emotional stability, self-control, loss of ability to do even simple tasks like swallowing eventually. So um, neuropsychologists will look at somebody's symptoms over time, uh, and ultimately you can only confirm that somebody had Alzheimer's disease at autopsy because Alzheimer's disease is actually caused by a buildup of protein, plaques, and neurofibrillary tangles. So this is protein buildup and tangles in your neurons as they degrade is actually required for it to be Alzheimer's disease. But if the decline in memory is severe enough, oftentimes we'll diagnose Alzheimer's disease because it can only be Alzheimer's disease or something similar that's causing the severity of symptoms. Ultimately, what's happening as these plaques and tangles build up is that you lose gray matter, brain matter in the hippocampus, the amygdala, and connections to the frontal lobe. Okay, so you get issues with memory from the hippocampus, emotions, control of emotions from the frontal lobe, self-control and emotional stability going on in the frontal lobe as well. Now, what are the causes of Alzheimer's disease? Well, there's a lot of research into this, and there's a lot of risk factors, but there is relatively high heritability. It runs in families, and there are also early onset conditions like Down syndrome. People with Down syndrome are much more likely to develop Alzheimer's disease early than people without without Down syndrome, suggesting there's a genetic link, perhaps particularly on chromosome 21. There's also risk factors particularly related to cardiovascular health. Blood flow, oxygen levels, blood oxygen levels, heart health, lung health. And so there may be some issues with heart and cardiovascular health over time, where if you're not getting blood flow and oxygen flow to certain parts of the brain over time, they may start to degrade and build up plaques and tangles. You can see in figure 10.14 the distribution of some of these plaques and tangles, and you can see how you might see some relationships between the location of the damage and memory and cognitive function. So a lot of what's going on is here around the hippocampus, the temporal lobe, and the amygdala. There's also a lot of issues here in the frontal lobe where we do complex cognitive processing. So in Alzheimer's disease, you get buildup of these plaques and tangles around the hippocampus and the temporal lobe. So you get memory issues from the prefrontal cortex. So we get working memory and cognitive control issues. There's also some issues here in the posterior parietal cortex, which is oftentimes involved in attention. So there's some attention issues as well. And that's going to be it for disorders. Next time, we're going to talk about recovery and reorganization.